Good morning students, welcome to this live class. I'm Cleeta your mathematics educator for KCET on Unacademy. Students, I'm a postgraduate in mathematics and I've been taking up KCET classes for quite a long time now with Unacademy. And in today's class, we will be discussing about the questions on complex numbers. So far, we have had several classes on the same topic, and today I will be continuing with many more questions on the concept here. So before I start the class, students, let me quickly request you all to subscribe to our YouTube channel, right? Click there, the subscribe button, and do press the bell icon to keep yourself notified with all the classes that will be happening on our platform here. Students, in the description of this video, you will find the link to my profile, so do click on the link and do follow me on the Unacademy platform. I will be starting up with a series of special classes starting from tomorrow on different concepts there. So do not forget to follow me and to check out the classes that I will be taking up. In case if you are new to the platform, if you haven't subscribed yet, to get the free access to the special classes, you will need the code. So do not forget to use the code, that is my name, Cleeta. Using this code, you will get the free classes access. Note down this code, students. This will also be helpful while you are grabbing your plus classes on our platform. As you can see, by taking up plus classes on a platform, you will have premium content at a very affordable price. There will be live classes, live doubt clearing sessions. Along with that, in these lectures, you will also have quizzes which will be conducted at regular interval. You will also have the access for the complete batch preparation courses, and also you will have the access for test series, mock test, where the analysis will be given to you all on your performance right after you complete the test. And with a single subscription, you will also have the unlimited access to the classes of all the educators. Yes, I'm right. You will get the access to the classes of 20 plus top educators, wherein you have the access for 10 plus batches, 250 courses, 2000 lessons, and many more, which will be added on soon. We do have different plans. As you can see on the screen, the 6 months plan will be at Rs 10,125, which will be at Rs 1,688 per month, wherein the 12 months plan will be at Rs 12,375. So these are the few of the batch preparation courses, students, as you can see on the screen, and we have the one more, that is Champions Batch. If you're looking for something as a trial period, you could take up the trial membership on a platform at Rs 2,250 only. So while you're getting a plus subscription, do not forget to use the code. You will get 10% off using the code given here. To check out for the link for the plus classes, please do click on the downward arrow next to the lesson and you will find the link to the plus classes as well. Do click on that and do explore these different subscriptions that we have for the plus classes. Yes, students, if you have any questions while we are solving here, you could always write down them in the chat box here. I will be able to help you out with the clearing of the doubt. So let us begin with the class today. Let us start with the first question for the class. So here you have the first question. If the complex number z is equal to cos of phi plus iota times sine of phi the whole square, then what will be the value for 1 plus z divided by 1 plus z conjugate? This is the question, students. Okay, so let me give you all few seconds to attempt the question. Please give me your options in the chat box. Okay, take 30 seconds and give me your answers. After that, I will be solving this question for you all. Right, so let's start with the solution. Just a second, students. the complex number z, this is equal to cos of phi plus iota times sine of phi the whole square, right? If I have to take modulus of z, okay, modulus of z here in this case will be modulus of cos of phi plus iota sine phi the whole square. Am I correct? And what will be the modulus here in this case? Root of cos square of phi plus sine square of phi and the whole square of this. So we have this as cos square of phi plus sine square of phi, and this value here is equal to 1, students. So we have the modulus of given complex number as equal to 1. So we can say modulus of z, the whole square value is also equal to 1. So we have this relation, z into z conjugate value is equal to modulus of z the whole square, right? So using that property, we can say z into z conjugate value, this is equal to 1. So let us replace for z conjugate. So what will be z conjugate equal to? Z conjugate here in this case will be equal to 1 by z. Okay, we are asked to get the value for 1 plus the complex number z divided by 1 plus z conjugate. So let's substitute for z conjugate now. So we will have this as 1 plus z divided by 1 plus 1 by z. So simplifying the denominator is going to be z plus 1 divided by z. So 1 plus z and z plus 1 will cancel out. So what do we have? 1 divided by 1 by z, and this value will be equal to z. Right? So given the option D. Right? So this will be the right answer for the question given here in this case. Yes, I hope you guys are following the solution. So meanwhile, let's proceed with one more question for the class students. So this is the next question. I am giving you all 30 seconds of time to figure out what would be the right answer here. The question is 1 plus iota divided by 1 minus iota raised to the power 1 factorial plus 1 plus iota divided by 1 minus iota raised to the power 2 factorial plus so on up to 1 plus iota divided by 1 minus iota raised to the power 212 factorial. So give a try to this question and give me answers in the chat box, students. So yes, students, let's quickly understand how we're going to simplify. We have 1 plus iota divided by 1 minus iota, right? This is a term that is raised to the different powers there, right? So simplifying 1 plus iota divided by 1 minus iota, this will be simply be equal to iota. Okay, so 1 plus iota divided by 1 minus iota, this will be equal to iota. Now let's check for the values. 1 factorial, this is 1. 2 factorial is equal to 2. 3 factorial will be equal to 6. 4 factorial, right, this will be equal to 4. From now on, all the terms here will involve the number 4 up to 2012 factorial, this will be 4 times some positive value k. Am I correct? Here also this is 4 into 3. So from now on, all the numbers from 4 factorial onwards, right, up to 2012 factorial, these all are going to be multiples of 4. So you have studied this concept, powers of iota. Whenever iota is raised to the power that is a multiple of 4, the value will be equal to 1. Similarly, iota raised to the power 4n plus 1. This will be equal to iota. Iota raised to the power 4n plus 2. This will be equal to minus 1. And iota raised to the power 4n plus 3. This will be equal to minus iota. So we will use this understanding now in simplifying. So let me quickly show you all the questions. So what was the question? 1 plus iota divided by 1 minus iota raised to the power 1 factorial plus 1 plus iota divided by 1 minus iota raised to the power 2 factorial, and the next term here will be 1 plus iota divided by 1 minus iota raised to the power 3 factorial, and this continues, right? After that we will have 4 factorial, 5 factorial and so on. So we will have the solution here, 1 plus iota divided by 1 minus iota raised to the power 1 factorial, right? 1 factorial is 1, so the first term will be iota. The second term is 1 plus iota divided by 1 minus iota, right? That is nothing but I raised to the power 2 factorial. So this will be iota square. The next term is iota raised to the power 6, and the next term onwards, that is iota raised to the power 4, 4 factorial, iota raised to the power, and so on. As we know, these values are going to be equal to 1 here in this case. So how many terms are remaining? 2012 minus 3. So we will have 1 added almost 2009 times here. Okay. Now what is the value for iota square? Iota square is minus 1. What about iota raised to the power 6? Right, iota raised to the power 6 is of the form iota raised to the power 4n plus 2, that is also minus 1. So 2009 minus 2, the value will be 2007, and we have plus iota here. So this will be the right answer for the question, students. So option number 2 will be the correct answer for this given question here. Yes, did you all follow the solution? Students, please do introduce yourself if you guys are watching this live class, and if you have any doubts, you can also raise your questions here in this live lecture. So this is the next question that we have. If z conjugate plus modulus of z is equal to 2 plus 8 times iota, then what will be the value for modulus of z? Okay. So let me quickly note down the question. Z conjugate plus modulus of z, this is equal to 2 plus 8 times iota. So what will be the value for modulus of z here in this case? We know modulus of z will be always a positive quantity or equal to 0. So let's consider, okay, let modulus of z be equal to r, where r is greater than or equal to 0. So let me substitute in the given equation. So I have z conjugate plus r, this is equal to 2 plus 8 times iota. I am rearranging this equation, students. You will have z conjugate as 2 minus r plus 8 times iota. So let's get the modulus of z conjugate now, and this is going to be root of 2 minus r the whole square plus 8 square. Even if you take the square of this, right? So we will have the values here as 4 plus r square minus 4 times r plus 64. When you have modulus of z, students, this value will be equal to modulus of z conjugate, right? Where modulus values are equal, square of them will also be equal. So we have modulus of z value as r, right? So what will be the value for modulus of z the whole square? This will be r square. So we have modulus of z conjugate also equal to r square. So I am substituting r square is equal to 68 minus 4r plus r square. So r square will cancel out given r is positive or equal to 0 here in this case, right? And rearranging this equation, we have 4 times r is equal to 68. This implies the value for r here is equal to 17. Yes? I hope you guys are following the solution. So the right answer for the given question here will be the modulus of z value will be equal to 17, students. Okay? The option number 4 is the right answer for this question here. So let us proceed with the next question for now. So here you have the next question. If x plus y times iota is equal to square root of 3 plus iota divided by 1 plus 3 times iota, then the value for x square plus y square, the whole square, will be equal to which of the following? So whenever we have complex numbers, you all can remember this as the general form. Let me give you all this equation. Remember, whenever you have the sum of two squares, here in this case x square plus y square, right? In terms of complex numbers, students, you can have the factors of this as x plus iota y multiplied with x minus iota y. Okay, remember this. Whenever you have the sum of the squares of two variables, you can split this in terms of factors having complex factors here as x plus iota y into x minus iota y. Now we are asked for the value for x square plus y square, the whole square. So what will this value be equal to? This will be x plus iota y, the whole square, into x minus iota y, the whole square. In the question, we are given x plus iota y value, that is root of 3 plus iota divided by 1 plus 3 times iota. So when you square this, right, x plus iota y the whole square will be 3 plus iota divided by 1 plus 3 iota. Yes, I have one student giving me the right answer. Good. Yes, that indeed is the right answer. So given x plus iota y value, right, we can get the conjugate x minus iota y. This will be root of 3 minus iota divided by 1 minus 3 times iota. So when you square this, you will have the value as 3 minus iota and 1 minus 3 times iota. So multiplying these factors, students, you will have this as 9 plus 1 divided by 1 plus 9, which is nothing but 10 by 10, and this value will be equal to 1. Yes, option number 3 is the correct answer for the given question here. Right then, students, let's proceed with the next question. Here we have the next question. If modulus of z plus 4 is less than or equal to 3, then the greatest and the least value of modulus of z plus 1 are which of the following? Okay, if modulus of z plus 4 is less than or equal to 3, then the greatest and the least values of modulus of z plus 1 are which of the following here in this case? So, as in a quick revision, right, modulus of z value, this will be always greater than or equal to 0, students. Similarly, modulus of z plus 1 value will also be always greater than or equal to 0. So the least value that modulus of z plus 1 can have, right, this will be equal to 0. Now let's check for the greatest value given to us in the question. We have modulus of z plus 4, this is less than or equal to 3. So we'll use this given value, right? So we will try to get the maximum value that modulus of z plus 1 can. Given modulus of z plus 1, right, what is the other value that we have given? Modulus of z plus 4, this is less than or equal to 3. So we'll try to express z plus 4 sorry, z plus 1 in terms of z plus 4. I will take this as z plus 4 minus 3. So we have this property modulus of z1 plus z2. This will be less than or equal to modulus of z1 plus modulus of z2. So we will take this as modulus of z plus 4 plus modulus of minus 3. Okay, we have the value for modulus of z plus 4. This is less than or equal to 3, and modulus of minus 3 will be also 3. So the value here will be equal to plus 6. So modulus of z plus 1 is less than or equal to plus 6, and it is greater than or equal to 0 here. So the right answer for this question will be the option number 2, that is 6, 0. Yes students, I hope you guys are understanding the solution. If not, please do leave your messages, or if you have any queries, you can write down in the chat box there. I will be able to help you out with the solution for the same. So let's proceed with the next question for now. So here we have the next question students. Given z is equal to 11 minus 3 times iota divided by 1 plus iota, if alpha is a real number such that z minus iota into alpha is purely real, then what will be the value for alpha? Okay, so let's solve this. So this is a given complex number. Let's quickly get it in the standard form by multiplying, dividing by the conjugate of the denominator. So we will have this as 11 minus 3 times iota, and then we have minus 11 iota plus 3 times iota square, that is minus 3, divided by 1 minus of minus 1, so this will be 1 plus 1. So simplifying, we will have this as 8 minus 14 iota divided by 2, and we will have this as 4 minus 7 times iota. So we are asked to get the value for alpha such that z minus iota into alpha, this is purely imaginary. When a complex number is purely imaginary, the z conjugate will be equal to negative times z. So if z minus iota into alpha is purely imaginary, then conjugate of this should be equal to negative times z minus iota into alpha. First of all, let's get this value for z minus iota alpha student. This will be 4 minus 7 times iota minus iota times alpha. So this will be 4 plus iota into minus 7 minus alpha. Am I correct? When we say, sorry, the question is to get the value for alpha given the complex number is purely real. When this purely real, we should have z conjugate is equal to z, or the imaginary value here will be equal to 0. So this implies minus 7 minus alpha, this is equal to 0. So the value for alpha is equal to minus 7. Okay, so the right answer for this question will be the option number 3, that is minus 7 here. So here we have the next question. If a square plus b square plus c square is equal to 1, where a, b, c are some real values, then what will be the value for a plus iota b divided by 1 plus c? Okay, if a square plus b square plus c square is equal to 1, then what will be the value for a square plus b square plus c square equal to 1? So as we have discussed earlier students, right, whenever you have complex numbers, you can take a square plus b square. This can be expressed as a plus iota b into a minus iota b. Given to us, we have the equation a square plus b square plus c square. This is equal to 1. We can rearrange this and have this as a square plus b square. This is equal to 1 minus c square. Right?
we can take the factors of 1 minus c square as 1 plus c into 1 minus c. So we have factors of both the terms on the left hand side and right hand side of this relation. So let's quickly write them down. So this will be a plus iota b into a minus iota b, and this is equal to 1 plus c into 1 minus c. Given to us in the question, we are asked for the value for a plus iota b divided by 1 plus c. So let's note down the factors a plus iota b divided by 1 plus c. Rearranging, this will be 1 minus c divided by a minus iota b. Okay, the option number 2 will be the right answer for this question here. So here you have the next question. If root of 8 plus iota raised to the power 50 is equal to 3 raised to the power 49 into a plus iota b, then what will be the value for a square plus b square? So given this condition, what will be the value for a plus iota b? This will be equal to root of 8 plus iota raised to the power 50 divided by 3 raised to the power 49. So if we have to take the conjugate of this a minus iota b, right? The denominator term is a real number, so the conjugate of the numerator would be 8 minus iota, and this is raised to the power 50 divided by 3 raised to the power 49 here. We are asked for the value for a square plus b square, right? In terms of the complex, given complex number, students, this will be a plus iota b into a minus iota b, and what are the values that we have here? Root of 8 plus iota raised to the power 50 into root of 8 minus iota raised to the power 50 divided by 3 raised to the power 49 into 3 raised to the power 49. So we have this in the form, right? A plus iota b into a minus iota b. So this will be nothing but root of 8 the whole square, that is 8, plus minus iota the whole square, that is nothing but plus 1 raised to the power 50 divided by 3 raised to the power 98. 8 plus 1 is 9. 9 raised to the power 50 divided by 3 raised to the power 98. 9 is nothing but 3 square. So the numerator will be 3 raised to the power 100 divided by 3 raised to the power 98. This is nothing but 3 square, students, and the right answer here will be equal to 9. Okay, the option number 3 will be the right answer for this question given here. So students, if you haven't subscribed to our YouTube channel, quickly click on the subscribe button and do not forget to click on the bell icon to keep yourself notified with all the upcoming classes that will be taken up here on the platform. If you would like to join in our special classes on the Unacademy platform, please do check out the link to my profile given in the description of this lecture. Click on it right away. You will be redirected to our Unacademy platform. To subscribe, to follow me on the platform there and join in my live lectures. As you can see on the screen, we have a plus subscription for the advanced preparation courses for KCET students, where you will be getting premium content at affordable price, live classes, live doubt clearing session, quizzes which will be helpful in clearing or understanding the concept better, the test series, mock test, where you will get instant analysis about your performance in the same. You will also have the access to the batch preparation courses on our platform, and all of this will be under a single subscription, right? With a single subscription, you are getting an unlimited access. So think about this, give a try and join in our plus classes. So we have different subscriptions, as you can see on the screen, for 6 months, 12 months, and also for a month as in a trial offer. While you're getting a subscription, do not forget to use the code. Using the code, you will get 10% off. So you can check out the description for the link to my profile and also for the link to our plus classes, and do use the code that is CLEETALIVE given in the description below. Yes students, it's time for me to wind up this class. I will see you soon with one more lecture. So till then, take care and let's crack KCET 2021-2022 with Unacademy, India's largest learning platform.